Good morning. Hello, guys. Am I audible? Am I visible? I can start quickly if everything is all clear. Although I have scheduled it from 9:30, so let's wait for a while. Then we'll go for our class. So today, what we're going to be discussing, we are going to discuss about Runge-Kutta method. Runge-Kutta. This is basically a numerical method mainly used in different programming, but this is in your CSIR-NET syllabus. So today we'll be discussing about this Runge-Kutta method. We'll not go into very much detail. We'll just tell you how to utilize Runge-Kutta method. If you are given numerical problem in your examination, then how you should tackle this method. That's what we're gonna discuss. Okay, so let's see whether am I audible or not. The sound is not great. What's the problem? I don't know. Maybe. Anyway, we can start if everything is okay. Anyway, we can start. Okay, so let me just tell you how Runge-Kutta method is different from the other methods. Like you conventionally, when you solve, let's say some differential equation, you have dy by dx equals to f of xy. So you conventionally get some solution y, and you get some solution. So what does it mean? It means you get a continuous solution of this. You get the dependence of the dependent variable with the independent variable. Now, how it is different in case of the Runge-Kutta method? In Runge-Kutta method, what we do it little bit in a different manner. It is not in this way. What happens in Runge-Kutta method? Here we know the solution at some point, and based on that solution, let's say x is equals to x naught, we know the value y naught. Now we cannot know like the solution in a continuous manner in Runge-Kutta method. In Runge-Kutta method, what you know, you define some interval, let's say delta x. So you get the solution at this point, let's say at x1. Okay, at x1 you will get some solution. And once you get the solution at x1, you can repeat the method, and you can get the solution at x2. Then you can get the solution at x3. This is how Runge-Kutta method is different from the other conventional method. This is basically a numerical method. So let's say you are given this differential equation, and let me just tell you another thing, that this Runge-Kutta method is used to solve the initial value problems. Okay, means some initial conditions will be given to you, and based on that you may be asked to find out the value after that. Okay, so let's say such a differential equation is given, dy by dx equals to f of xy, and some initial condition is given to you. What is that initial condition? The initial condition is at x is equals to x naught, you are given a value y is equals to y. Then what is our goal or target? Our goal is to find out the value of y, to find the value of y at some later point at x is equals to x naught plus delta x. So this is our target in Runge-Kutta method. Now how it is done? How it is tackled? So as you have seen, your x modified value x is equals to x naught plus delta x. Okay, this is not a problem. And let's say the value of y at that value of x naught plus delta x, it is once again it is given y naught. This was the initial value at x naught. So let's say the change in y is also is delta y. So if we somehow get to know this delta y, we can say that the value of y at x is equals to x naught plus delta x is this. Because y naught we know. So what remains is the delta y. Now there are some formula. Let's say delta x is equals to h. Now before moving further, let me tell you Runge-Kutta method. It has two orders, second order and fourth order. I don't know why first order and third order not there, because it depends on the number of terms. So in Runge-Kutta second order there are two terms, in Runge-Kutta third or fourth order there are four terms. That is why the name is. So anyway, so first we will talk about the second order. In the second order, as I told you earlier, that it will contain two terms. So I will show you. I will take a single example and will apply both second order and fourth order. We will see which method is more precise. Okay? Can you hear me properly? I think the voice is not so clear. It will be great if you just let me know. I don't know, this is a problem in the room. So let's say x is equals to delta x is equals to h, and the corresponding value of delta y according to the Runge-Kutta second part. This is Runge-Kutta second order. As per the Runge-Kutta second order, the value of delta y will be given by k1 plus k2 upon 2. Now what are these k1 and k2? So our ultimate goal was to calculate delta y. Delta y is given by k1 plus k2 by 2. And here your k1 is equals to h into f of x naught y naught. Okay? Because f is given to you in the first place, dy dx is equals to f of x. F is given to you. So k1 is equals to h into f of x naught y naught, and k2, the value of k2 is h into f of x naught plus h y naught plus k1. So first of all you have to find out k1, then you can find out k2, and once k1 and k2 are found out, you can easily find out delta y, and once delta y is found out, you can easily find out the value of y. So this is the second order Runge-Kutta method. This is a formula you have to remember, otherwise you cannot solve. And in the examination maybe, but it is highly unlikely that the formula will be given. So you have to remember it. So let us now solve a problem. Then we will understand how to apply this Runge-Kutta method. Okay. So we have a problem. Let's say dy by dx is equals to x plus y. This is the differential equation given, and the initial conditions are given like this. Given y at x is equals to 0 equals to 1. This is the initial condition. You have to find out y at x is equals to 0.2. So using Runge-Kutta second order. Runge-Kutta method of second order. So let's see how we solve this. So first of all, here your x naught. What is x naught? The options are given. I'm not giving the option. Let's do it for the time being. So x naught is the initial value. What is the initial value? Y at x is equals to 0. So x naught is equals to 0 here, and the value of x means the point at which you have to find out the value of y. It is x naught plus delta x. So you can see this is 0 plus delta x is 0.2. Okay, x is equals to 0.2, delta x is equals to your 0.2, and that is also h. You can see delta x is equals to h you have taken. So your first goal is to calculate k1. The value of k1 is h into f of x naught y naught. H into f of x naught y naught, h is 0.2, f of x naught y naught. What is f? F is equals to f of xy is equals to x plus y, right? So k1 is h into f of x naught y naught. So 0.2 x naught y naught is x plus y. F of xy is equals to x plus y. So you have to put x is equals to x naught and y equals to y. 0 plus y at x equals to x naught is 1. So plus 1. So this is point. You can find out the value of k2. The formula I have already given you, h into f of x naught plus h y naught plus q1. The value of h is 0.2, okay, into f of x naught plus h and y naught plus q. So you just put the value 0.2 plus y naught plus q. Y naught is 1, q1 is 0.2, so it is 1 point. And if you evaluate this, you can get a value of 0.28. So you got the value of k1 and k2. Therefore, we can find out the value of delta y. Delta y is equals to half of k1 plus k2. So half of k1 value is 0.2, k2 is 0.28. So if you evaluate this, you get a value of 0.2. So at x is equals to 0, the value of y is 1 and x equals to 0.2. The value is y naught plus delta y. Y naught was 1, 1 plus delta y is 0.24, so it is 1.24. So this is the value we get using the Runge-Kutta second order, okay, 1.24. So remember this value, 1.24. Now we are going to solve the same problem by using the Runge-Kutta fourth order, okay. So let's talk about that. Runge-Kutta method of fourth order. So as I told you, the order is defined as the number of terms, okay. So in the Runge-Kutta fourth order, the process will be similar. If you can follow the second order, you can easily follow the fourth order. So as usual, you will be given the differential equation dy by dx is equals to f of xy with the initial conditions. Initial condition is very important. This differential equation is solved from the initial conditions. Initial condition is must here. At this initial condition will be given to you in the question paper at x equals to x naught, y equals to y. This is the initial condition you have, and based on this initial condition, if I am asking you to find out the value of y at x naught plus delta x, okay, that is what you have to find out, okay. So here x is equals to x naught plus delta x, and similarly y will be y naught plus delta y. Now here the main concern is to find out this delta y, as I told you, but here delta y will be more accurate, more precise. Let's see the value of delta y, and as already delta x is equals to h, we have defined it earlier. Delta y, the value of delta y here in this formula will be, what is the value of delta y? Delta y now will contain 4 terms. 1/6 of k1 plus 2k2 plus 2k3 plus k4. Now here the evaluation of k1, k2, k3, k4, these 4 terms becomes a tedious job. In your examination you can expect the second order move. Fourth order is highly unlikely because it may take too much time, and it may also give you, because it will be given in 5 marks question. Anyway, just learn, because it's not that much hard. because calculators are allowed nowadays, so it will be not much difficult in the examination. Now the question is, what are these values of K1, K2, K3, K4? K1 as usual, K1 is same H into F of X naught Y. Look, you can multiply H in K1, K2, K3, K4, or you can also multiply H here in general. So I prefer this one. K1 is equals to H into F of X naught Y naught. K2, make a guess, what will be the value of K2? K2 will be H into F of, here it's a little bit different, X naught plus, this will be H by 2, and Y naught के साथ K1 बना, Y naught plus K1 by 2. This convention is there. K3 will be H into F of X naught plus H by 2, this will remain same, plus Y naught plus, here you see, in K2 it was K1 plus 2, in K3 it will be K2 by 2, and K4 it will be H times F of X naught plus H, Y naught plus, it should be K3. This is the case. So in this way you can have this. So this is your Runge-Kutta fourth order. Okay, na? This formula is Runge-Kutta fourth order. Now if based on this formula, if I tell you to solve the same problem as you have done before, okay, let's see how the precision changes. So let's solve this problem once again. So you are given once again dy by dx is equals to x plus y as usual, and the initial condition is also same. Y at x is equals to 0 equals to 1. You have to find that y at x equals to 2.2. So let's see how the answer changes. Okay, what do you expect? In fourth order, the precision should be more. Okay, so let's get back to the solution. Here x naught is equals to 0, delta x which is equals to h is equals to 0.2, and x is equals to 0.2. Okay, so let's calculate K1. K1, what is the value of K1? H into F of X naught Y naught. Let's write the formula. Okay, it's a good practice. H into F of X naught Y naught. So H equals to 0.2 F of X naught Y naught. So in place of X you have to put X naught. In place of Y you have to put Y naught. So X naught and Y naught. What is Y naught? Y naught is equals to 1. Okay. So 0 plus 1. So this is giving a 0.2 as usual. K1 value is not changing. Let's calculate K2. K2 is equals to H into F of X naught plus H by 2 Y naught plus K1 by 2. So this is 0.2 F of X naught plus H by 2. X naught is 0, H by 2 is 0.1. So 0.1. 0.1 plus Y naught plus K1 by 2. Y naught is 1. 1 plus 0.2 by 2 means 1. What will it become? 1.12. Okay, क्या हो जाएगा? Y naught plus K1 by 2. Okay, so let's calculate it. So F of X naught plus H by 2. So 0 plus H by 2 is 0.1. Y naught means 1 plus K1 by 2 means 1.1. Okay, so this is equals to 0.1 plus 1.1. So how much? 1.2. So this will give you around 0.24. So this is a value of, ओके यहाँ पे फिर हम लोग 1.2 टोटल 1.2 है, दिस इज 1.2. So 0.24 is the value of K2. Let's calculate the value of K3. K3 is equals to H into F of X naught plus H by 2 Y naught plus K2 by 2. Okay. So this will give you 0.2, and this is as usual 0.1, and this will be 1.12. And if you calculate this, you will get how much? 0.244. And another term is left, k4 h times f of x naught plus h. Okay, here it will not be h by 2, it will only h x naught plus h y naught plus k3. So this will become 0.2 plus 1.244. So this will become 0.288. So we get all the values. Therefore, we can find out delta y 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. Just put the values 1 by 6, 0.2, 0.48, 0.488. So k4 is 0.2888. If you evaluate these, you can get a value 0.2428. So you can see the difference in result. Here it is 0.2428, and previously using the second order we got only okay. So this is the value of delta y. You can easily find out. Let's first find out the value of y. Y will be y naught plus delta y. So it is 1.2428. So using the fourth order you get 1.2428. 1.2428, and using the second order we are getting 1.24. So obviously you can say that the second order it is less precise, the fourth order is more precise, so it is better to use fourth order. So in your examination, whatever order you have to use, it will be mentioned. Okay, so I hope you have understood how to utilize the second order and fourth order Runge-Kutta method. If you have any question, you can just let me know in the comment section. Okay, I will make it available for you. Guys, before I end the live stream, let me just tell you guys, you can follow me on Unacademy Plus. This is my profile. You can have a look at my courses by visiting this URL, https unacademy.com/physics hub. You can get all the detailed courses like mathematical physics, classical mechanics, electromagnetic theory, quantum mechanics, and many more. You can join Unacademy Plus today using our referral code Physics Hub to get the maximum benefits. You can get a lot of benefits like you get daily classes, part-length, full-length tests, assignments, proper structured course. Whole syllabus is covered, dedicated afternoon sessions of regulatory lectures, PDF of the study materials, class notes in both Hindi and English. Offline video recordings are also available, WhatsApp and Telegram group supports. This kind of fee structures are available on Unacademy. You can go for any of the plans, 3 months, 6 months, 12 months or 24 months. If you utilize this referral code Physics Hub, Unacademy will give you the maximum benefits. So thank you very much guys for watching this session. I hope you like this video. Just give this a video a thumbs up, and if you are new to this channel, please subscribe. Don't forget to press the like. Finally, thanks.